Obviously, what is presented here is the dragonfly. The dragonfly wing hides an important secret within them. If the image is enlarged to the nanoscale, like so, one can see the small structures sticking up in an almost carpet-like fashion. These small structures are called nanospikes. Most insects have this property, but not to the degree that a dragonfly has them. What makes the dragonfly wing so special? First off, one of its most useful properties is that it has an antimicrobial substance. This means that it will kill most, if not all, bacteria that touch its surface. An important question to ask is, how does it do this? Looking at this picture, one can see the microbes circled in yellow. Gravity is pulling the microbes into the sharp ridges of the material, and at the same time, the nanospikes are slicing into the microbes. The nanospikes are incredibly effective at this, and it does not take long nor much pressure before the bacteria is killed. The time it would take for this to happen is less time than it would take for one of these microbes to reproduce. It should be noted that even if it does reproduce, the offspring also get caught and become lysed in the same process once again. And they die. As one can imagine, a dragonfly's wing is not the most effective material for today's manufacturing. This is where black silicon comes in. Black silicon, which looks like this, and at the nanoscale, like the dragonfly wing, contains an almost identical nanopattern, as shown here. The black silicon comes with a few added benefits. Its main benefit is that it can be used in hip replacements. For an example, as shown by the paper, Antibacterial Titanium Nanopattern Arrays Inspired by Dragonfly Wings, black silicon is very effective at killing 90% or more of the bacteria that is placed on the plate. Black silicon is also a semiconductor, which shows its other use. Due to the material being a semiconductor, it allows itself to be used in solar panels. Turning to the astronomy. Due to their high absorbance in the infrared and visible spectrum, black silicon has high anti-reflective abilities. This material also reduces the spectral reflection found in many devices to the order of -7. It also suppresses infrared reflection. In the visible wavelengths, it reduces hemispherical total internal reflection to 0.1%. This would mean that black silicon would make an excellent detector given its inherent abilities. Scientists have already done this and have plans to implement it into telescopes as a coating, and as a detector in both spectrometers and coronagraphs, seen here. You can see the spectrometer, the coronagraph, and the lens coating. Thank you.